All right, it is 11:30 Eastern, which means it's time to kick off. So I'll give a little intro and then I'll hand it over to Edison. But yeah, as everyone in the audience knows, Story launched their $1 million competition a couple of days ago, and it ends on January 17th. So they're going to conduct a live code walkthrough in two parts. So the first one's today, this one. The second one's tomorrow, an hour earlier. It'll all be recorded and shared on our YouTube channel, which I'll drop into the Discord channel as well. So yeah, big thank you to the team for joining us today, and yeah, I'll let Edison take it away from here.
Between Story and Omni in terms of the using of two different clients, execution and consensus client, and connecting them through the engine API. Basically, that's the kind of the same as Ethereum, where like engine API connect the Bit engine and the execution client, where it can be a Geth, it can be REST, and some other like different execution client. And also, regarding that, we are using Cosmos SDK and Commie BFT as the consensus layer. Commie BFT basically is the Tendermint kind of consensus algorithm, and on top of that, we forked the Cosmos SDK to add a few customized Cosmos module and also update some of the modules. So there's one part that here. So these are the modules that we change, and one of these EVM engine, which actually it was inspired and actually largely used from Omni, which is used for connecting the ABCI and the engine API to make sure that the consensus flow kind of go through the basically the consensus and then build the payload on the execution layer. I will go through that part a little bit, but that's kind of the high level. And on the execution client side, we forked the Geth code, and we didn't touch mempool, but we add IP graph precompile, which is a stateful precompile. So if you're familiar with Geth, all the current precompile are stateless, but our IP graph precompile is stateful. Basically, it will assess the state. I'll go into that part a little bit later. And so in terms of feature, there are a few bigger changes we made. I put here. One is all the staking functions. The other is the IP graph precompile. So staking function means we have let me share this. So if you look at our documentation, we have a page that talk about our staking mechanisms, and a lot of other changes are made to implement that. So here in the layer one section, there's a tokenomic and staking. So here we talk about it's like our staking spec. We talk about different things on staking. We have the concept of lock and unlock token. We talk about token machines, and also we have different type of staking. Usually, the staking for layer one chains only have flexible staking. That means you can stake and then unstake after an unbound period. But we also have the concept of staking period, where you can stake. This is just an example for a few days to get a higher multiplier. And these changes are implemented in our Cosmos modules. Specifically, let me go back to like we have EVM staking module means staking distributions. So these are the things that we change to support these new features. And on the execution client side, we have our own staking contract, which handles the basically the figure of like the user interaction. So user only interact with execution client. Yeah, so that's kind of the high level diagram architecture. Here I can go through a few basic flow. So first is the staking flow, like how staking work in Story. Let's see. Let me reshare. Okay. Can you guys see now? Okay. Yeah. So I just went through the basically this diagram, which is kind of the high level architecture. Here is like basically two validators, and each of them will have execution client and consensus client, and the two clients communicate with engine API. And on the consensus client side, ComicBFT is the consensus algorithm running the Tendermint consensus. And then on top of that, there are Cosmos SDK modules that we kind of added. There are also some default ones we didn't change, but these are the ones that we touched. Okay, and then coming here for the different flows. So all the user interaction go through execution client. So execution layer is fully EVM compatible. That means like user can use the same kind of EVM, like Ethereum type of RPC to send transaction, and the staking will also go through the EVM side through our staking contract. So the high level flow will be users submit a staking transaction to our storage staking contract on the execution, basically EVM side. And then the staking contract do nothing but just emit the EVM events with all the user input, for example, how much the user want to stake, and which like how long the period is, and that events is actually uh, received by the consensus client through the engine API query, and then the client's consensus client will process these events and update for example, the staking balance and other parameters, the states in the consensus client. So our staking contract is mostly stateless. The reason I point out this is that some people may ask, oh, like how does the like basically the staking contract doesn't track any state. All the states, or most of the states, except some of the like the parameter that use for verification, the input, are tracked on the consensus client as a single source of truth. Because we realize that it's very hard to synchronize between the staking contract and the consensus size for the states. That's why we store the states in as a single source of truth on the consensus side. That means a lot of verification that require the states will be in the consensus side. Okay, so that's the staking flow, and the second is the transaction lifecycle. This is actually tied to the basically the architecture that but so yeah, so we actually tie together with the block proposal and the consensus flow. But as from a transaction point of view, user will submit the transaction through the normal EVM like JSON RPC, and the transaction will go to Ethereum client's mempool, the mempool on the execution side. And then when a validator uh, we need to propose a block, which is basically on the consensus side. So Comet DFT consensus algorithm will determine who is the next proposer, and then when next proposer come in, it will call the execution client through the engine API to build a payload. Payload is basically the content inside the block, and the execution client will get all the transaction in its own mempool and build a payload and send back to the consensus clients. And consensus clients will use this payload to build a block. And then after building the block, it will broadcast the block through the P2P network, basically propose the block as a proposer. And then after that, the other validators in our network will receive and verify the block to see, and with their own states. And if the more than 2/3 of the stake vote yes to the block is accepted, and then the transaction that in the block will be applied to each validator so that they will update their state based on the transactions. So that's the kind of the high level TX transaction lifecycle for like how like story actually work from the execution side to consensus side. And here I also write, this is more to help you understand the most important function in code in story, which is ComicBFT has this ABCI plus kind of interface, and Ethereum have this engine API interface. So one thing that basically we have is both of them are doing the similar things. Basically, there will be a time that you need to propose a block, right? And there's a time that you need to verify blocks. So in Common BFT, basically, whenever you want to propose a block, you prepare a proposal. And then, but during the prepare proposal, you need to build a payload. So in that case, you'll call the engine API. fork trust updates endpoints to kind of propose that block. And same thing on the verification side. On the whenever someone a validator receive a block, you need to verify that block, and that will call the process proposal and functions in our Codebase, and then basically as the Cosmos SDK, and then in turns we'll call engine API new payload on the execution side in order to kind of verify that payload. Because the state, some of the kind of the transaction states sits in the execution client. Okay, so that's kind of the high level staking flow and transaction flow and the architecture diagram. So next, let me share this tab. So let me know if you cannot see it. But this is basically our Cantina story page that we list all the document. So all the different repository that we make code changes and all the documentation is listed here. Specifically, we put like there are a few repository. First is our consensus client, which is story, PaperLab story. And next one is our execution. We fork Geth and made some modification in terms of file. We mainly add the IP graph precompile, and we have another precompile for the SEP 25.6R1. This is basically to support the EIP 7212 for the passkey. But these are the changes we've made for to the execution client. So that's story Geth. And another one is we also fork Cosmos SDK. So it's in this branch, basically to support our staking function that I mentioned earlier. So we modify the staking module, we modify the distribution module, and some, I believe, some of the 1 or 2 line in the session module. But if you go here, we can go through together that like the different commits that we made. And eventually, here this will be covered tomorrow on the proof of creativity protocol. These are our smart contracts on top of the layer 1 that tomorrow Kinter will cover. Okay, so then let's go through these 3 repo briefly. So I'm sharing the story repository, so let me know if you cannot see. So in terms of the repository, the most important folders, and I believe also mentioned in the scope is inside the client. So inside the client, this is actually a Cosmos SDK application. You're familiar with a Cosmos SDK. The 2 most important folder, one is the application folder, which basically bootstrap the applications and the basic ABCI function. So here, actually, we implement a wrapper on top of Cosmos SDK and ABSCI. And the code basically start here from the start.go. And that's the basically step that we start do all the configuration, assume the flag, and run the nodes by starting both Cosmos SDK app and Commit BFG. So that's kind of this entry point for our Codebase. The second important, probably the most important then is part is our modules. Module basically implements some of the functions that like customize the Cosmos SDK to include some of the business logic. So here we have the EVM engine module I mentioned earlier that is kind of inspired by the Omni team. So basically here there are the code where it's mostly communicate between the consensus and execution, basically translate the ABCI function call to engine API function calls. So for example, there's abci.go here, which have how the prepared proposal is handled. Right? Eventually, it will call the engine API here, and also how, for example, verification process proposal is handled. So this is for engine EVM engine module. The next one is EVM staking module, which is our basically own module here. It mostly handle the logic is mostly in a key profile. It mostly handle different types of events that we accepted from the EVM side. So I mentioned about the staking contract and the staking flow that we basically consume the EVM events and then translate them to the consensus states. For example, deposit will mention how we process the deposit event from the staking contract. And like, for example, some other files like redelegation, how we process redelegations, and some other different logic here. So when you look at this, it's probably easier if you look at our staking spec and to check like what's the right behavior here in terms of like deposit withdrawal and redelegate and some of the other functions. Okay, yeah, so that's kind of the biggest module. We also use Cosmos SDK's mint module, but do some modifications since we have different minting like schedule. So and the current Cosmos SDK doesn't support that, so we also did some modification here. So that's pretty much high level of the like story clients. There are some other folder here which has some let's go. I think some of these are in the scope, but a lot of these are like Genesis util and configurations stuff which are not in the scope of the auditing. So yeah, so that's kind of pretty much on the story side. We come back to this page. So the next one is our Cosmos SDK fork. So I'm sharing the Cosmos SDK fork here. Let me know if you cannot see it. So in our Cosmos SDK fork, we put our changes in our own branch. And if you want to look at the difference between our changes and the main branch, uh, you can look at basically the commit. We didn't make. I think the biggest commit is here, which is because we kind of do a squash and since we update the Cosmos version early on, so these are actually a big commit that touch many file. But so you can use this as a reference, but then also look at the branch itself. So we made changes to, if you look at it, some of these are just tests to, but then distribution module, we made some changes to evidence module actually, and then some of these are just tests. Session module, staking module. Yeah, so that's the main changes on the module side. Yeah, these are just most of these are just tests. So we mainly modified the modules. Staking and the distribution is the main things that we modified in order to support the new staking instance that we implemented. Okay, so coming back. So next one is the story get. Um, sure. Yeah, here the main changes as noted in the document is on the precompiles. The first file is we basically add a precompile in this file. So here it lists different precompiles in different hard fork. So we add our IP graph precompile. So where the actual code for the precompile is under the ipgraph.go. So this is the main file that we need help to look into. Yeah, so it will mention like some different functions and also the gas required for executing this print compile. Yes, so and just one maybe one quick kind of context for this is that some of these are our business logic. So if you're great, you can look at this with our documentation about how the sort of protocol doing in terms of allowing people to register IP items and also gain royalty, because some of the function here is um, basically set royalties and set the IP graph parents. So the whole goal here is to have allow the ability for users or the protocol to build the IP graph on chains to keep up the relationship between different licensing and royalty stream. Yeah, I think that pretty much it for kind of a high level overview of both the architecture and the code base. So, but yeah, if you have any questions, feel free to ask.
So, yeah, as Edison said, if anyone has any questions, feel free to drop them in the chat. We've got one question so far. So, one from Dontonka. Why is your customization of Mint module not fully part of the Cosmos SDK fork as your customization of staking, slashing, distribution evidence, etc., and instead is in your repo, story repo X override?
So the question is, why the Mint module is not also a customization?
Yeah, why is it not
Um,
not fully part of the Cosmos SDK fork and is in the story repo X override instead?
Yeah, I think it can potentially be. It's because we did the main module first. Also, main module doesn't have any dependency. So I think initially we think we probably need to do the whole main module. That's why we fork it. And then we do, and also main module is kind of like, in terms of the module dependency is at the highest level, so that it won't like the other module that depends heavily back the Cosmos module, so that we kind of directly port it to our own repository and then made modification. And later on, when we want to modify the staking and the distribution module, these modules are used in independent, like intertwined with other Cosmos module. So it's making it very hard to kind of extract it out because of the dependency kind of graph. So it will have maybe like the dependency between each other and also between our own like story size Cosmos module. So then we decide, okay, actually let's fork the Cosmos SDK. Yeah, so that I think that's kind of the high level reason. But if originally it's in the the audience, maybe everyone's I remember that was the main reason.
Oh, no, more typing. Awesome. Looks like we're good. As I said before, I will upload the recording on YouTube as soon as I can, straight after this, and then I'll share it in the channel in Discord, so it'll be there for anyone who had issues seeing the screen. But yeah, huge thank you to the team. We'll be back for the second walkthrough at 10:30 Eastern tomorrow morning, so we will see you all there. And yeah, big thank you to the story team.
Thank you, and hope you guys have fun.
Have a good day, everyone. Bye.
Cool.